Hello everyone. Today I am going to tell you some concepts. These are the concepts in from BTech in first year. Subject is engineering mathematics 2 and lesson is complex numbers. So first we will see D Moivre's theorem. This theorem says if you take a complex number written as cos theta plus I sin theta and raise it to any real number power n, then cos theta plus I sin theta bracket raised to n is equal to cos of n theta plus I sin in bracket n theta. It is meant that imagine you have a complex number that lies on the unit circle, meaning its magnitude. Unit circle means its magnitude is 1. It has an angle theta with the positive real axis. De Moivre's theorem tells you how to find the result of raising this number to a power just by multiplying the angle theta by n. So instead of multiplying out complex numbers repeatedly, you can do one simple operation on the angle. But why this is useful? It simplifies powers of complex numbers. It helps in converting between rectangular and polar forms. It's useful in fields like electrical engineering, quantum physics, and signal processing. Now we will see how to find roots of a complex number using De Moivre's theorem. So here I given the theorem. If asked in exam paper, you can refer this. I hope you we will I hope you will understand how to find roots of a complex number by seeing an example. So first let's see example. Question is find all values of I bracket raised to 1 by 4. So here solution is, first we have to express I is equal to cos pi by 2 plus I sin pi by 2. This is because I lies on imaginary axis at an angle of pi by 2 radians from positive real axis. So next our step is generalize the angle using periodicity. Any complex number has infinitely many representations in polar form due to periodicity. So I in is equal to cos in bracket 2n pi plus pi by 2 plus I sin in bracket 2n pi plus pi by 2. After simplifying it, it gives cos in bracket 4n pi plus pi upon 2 plus I sin bracket 4n and pi plus pi by 2 bracket. So now our next step 3 is take the fourth root. To find I raised to 1 by 4, we take the fourth root of polar form. That is I raised to 1 by 4 is equal to in bracket cos in again bracket 4 and pi plus pi upon 2 plus I sin in bracket 4 and pi plus pi upon 2 bracket and then complete bracket and raised to 1 by 4. Using De Moivre's theorem is equal to cos in bracket 4 and pi plus pi upon 8 plus I sin in bracket 4 and pi plus pi upon 8 is equal to cos in bracket n pi by 2 plus pi by 8 plus I sin in bracket n pi by 2 plus pi by 8. So now our next step 4 is put values of n is equal to 0, 1, 2, 3 for all 4 roots. When n is equal to 0, cos in bracket pi by 8 plus I sin in bracket pi by 8. When n is equal to 2, cos in bracket 9 pi by 8 plus I sin in bracket 9 pi by 8. So like this, put n is equal to 3 and n is equal to 1 also, and this will gives you 4 roots of this complex number. So this is the procedure to finding roots of a complex number. So we will see next example. try this example on your own basis and then see the solution. So here is question: find all values of in bracket half plus I root 3 by 2 bracket complete raised to 3 by 4 and show their product is unity and show that their continued product is unity. So first step is here, convert the complex number into polar form, that is z is equal to half plus I root 3 by 2. So let's first find magnitude and angle. So r is equal to under root half square plus root 3 by 2 square is equal to tan theta is equal to root 3, that is 3 theta is equal to pi by 3. So z is equal to cos pi by 3 plus I sin pi by 3. We now its generalized form is z is equal to cos in bracket 2n pi plus pi by 3 plus I sin in bracket 2n pi plus pi by 3. So now we will raise to power 3 by 4. Now apply De Moivre's theorem again. Z raised to 3 by 4 is equal to cos in bracket 2n pi plus pi by 3 plus I sin in bracket 2n pi plus pi by 3 and give whole bracket to this and raised to 3 by 4. Now multiply angle by 3 by 4. So it will give cos in bracket 3 by 4 again bracket 2n pi plus pi by 3. Now complete both the brackets plus I sin in bracket 3 by 4 again bracket 2n pi plus pi by 3. Now complete these both two brackets. Now after simplifying it, it will give cos in bracket 6n pi plus pi upon 4 plus I sin in bracket 6n pi plus pi upon 4 is equal to cos in bracket 3n pi plus 3n pi upon 2 plus pi by 4 plus I sin in bracket 3n pi plus by 2 plus pi by 4 bracket complete. Now put values in 0, 1, 0, 1, 2 and 3. So after putting these values, you will find cos pi by 4 plus I sin pi by 4, cos 7 pi by 4 plus I sin 7 pi by 4, cos 13 pi by 4 plus I sin 13 pi by 4 and cos 19 pi by 4 plus I sin 19 pi by 4. So for finding its continued product, so multiply these four values. Like here you can see a0 a1 to a0 a1 a2 a3. Here product is taken and after polar form is given and is equal to cos in bracket pi by 4 plus 7 pi by 4 plus 13 pi by 4 plus 19 pi by 4 plus I sin in bracket 5 by 4 plus 7 pi by 4 plus 13 pi by 4 plus 19 pi by 4 is equal to cos 10 pi plus I sin 10 pi is equal to 1. Cos 10 pi value is 1 plus I and sin 10 pi value is 0. So 1 plus 0 is 0. So like here we find continued product is unity. So I hope you understand and this De Moivre's theorem and roots of finding it. Try on your own basis, refer these examples. You can write this exam, you can refer of method of writing this example. Thank you.